All right, guys, in this video, we are going to finish up the section 5.5, and this is on polar coordinates. Now, the last video, if you did not see video A, then make sure that you go back and watch that because it is all about being able to plot the coordinates and, and even look at a point and tell what other types of coordinates there would be because there's infinitely many ways to name a coordinate point. Now, for this lesson, we're going to actually start practicing being able to go between rectangular and polar coordinates. And because you can represent a point in many ways. It's not just one way or the highway. So you can represent points in a rectangular coordinate system, but you can represent the same points in the polar coordinate system. And so we need to talk about how we can go back and forth between the two things. So what y'all will see here is you'll see some nice little pretty pictures as to how these different systems relate to each other. If I saw this point that was shown in a rectangular system, you see the X and Y system here, then that's how we would name that point. However, with polar, that's when we look at this R and this theta, but I can still represent the exact same point using that system. Since you can represent the same point with the different systems, then if we were to kind of put these ideas together, you can actually see them side by side and how the two systems compare to one another. So if I was just looking at this point right here, I can represent this XY, but also that R theta. And when you put it together, we see a little right triangle. And that right triangle gives us a lot of options because we have learned so many things about right triangles. We have Pythagorean theorem, we have trigonometry, and that allows us to be able to compare the sides and the angles and find different values. So we're going to practice being able to go back and forth between the two different things. But let's go to the next page of our packet and you will see our first little relationship to let us do some of this. So this first box right here, it says we are converting from polar to rectangular coordinates. So just to give you a quick little rundown, we've got this little scenario here, right? And we are able to know, based off of all the information that we know about this scenario, that I can actually compare and relate different sides to each other. I could, if you look at angle theta, I could look at sine, cosine, tangent of theta. If I looked at cosine, that's adjacent over hypotenuse, x over r. And that's what you're seeing right here, cosine of theta, x over r. If I wanted to talk about sine, sine is y over r, the opposite over hypotenuse, right? So sine of theta is y over r. Now what they did is they took these two little relationships and they said, well, let's write it without a fraction. Let's multiply both sides by r. That would make r cosine theta, and it would cancel on this side, just making an x. And this gives us our first big idea. From the rectangular system, x is going to be equal to r times cosine of theta. And similarly, we've got a big idea. If you multiply both sides of this by r, you'd get r sine equals, it'd cancel out there, y. So y is equal to r sine theta. These big ideas allow us to be able to represent these values. Now I'm going to try to keep that up in the top corner, but we're going to work here through example A. All right, first thing, this guy has given us, if you read it, polar coordinates. We have been given an r and we've been given a theta. All right. So if we've been given r and we've been given theta and we're supposed to convert this to rectangular coordinates, here's how we're going to do that. We are going to take this relationship up here. We know that x equals r cosine theta. So I'm going to say x equals my r cosine theta and plug those values in. R happens to be 2 cosine of pi. Now, cosine of pi, I can get that from my unit circle. You imagine going out to pi, and cosine of pi is going to be -1. So this is 2 times -1. 2 times -1 is -2. That gives you the x coordinate. All right, let's talk about our y-coordinate. Y-coordinate, same kind of way, but we're using the second one. We want r sine theta. All right, so that's 2 sine of pi. All right, so sine of pi is actually 0. Go to pi, look at the y-coordinate, it's 0. 2 times 0 is 0. So although my polar coordinates are 2 pi, my rectangular coordinates, the x and y, -2, 0. Ta-da! Now, you can try to decide if that makes sense or not, right? If you were to imagine this being on your polar system, okay? If I was looking at 2 pi, I'd be going out, okay, 2. But then pi means that I need to wrap around my polar system to the other side. And that would be where the point was. So 2 pi, that's kind of the system for it, right? You go out to 2 and then you go around pi. But that happens to also be the exact same point as -2, 0 from my x coordinates, x and y coordinates. Okay, we are going to do one more example here. I want you guys to pause the video and try B. And when you are ready to go over it, start the video back. All right, they've given us an r and a theta. We're going to plug these in. So x is equal to r cosine theta, just like before. But we're going to plug this in as 4 times cosine of 5 pi over 3. All right, so 4 times cosine of 5 pi over 3 should give you 1/2. And then 4 times a half would give you 2. That is your x coordinate. Then I need my y coordinate, right? So we did the x, now we need y the same way, but use the other relationship. Y equals r sine theta for sine of 5 pi over 3. Okay, so this is 4. Now sine of 5 pi over 3 is negative square root 3 over 2. And then if we multiply that together, you can simplify this a little. 2 goes into 4 twice. So that allows you to kind of clean this up a little bit. 2 times the negative square root of 3 is -2 square root 3. So my final coordinate here would be 2, -2 root 3. Ta-da! All right, so that's that one. Now let's talk about going the opposite way. If we talk about the opposite way, that would be this guy. So going from rectangular to polar. From rectangular to polar, we are going to end up using our Pythagorean theorem. It's just easier this way than trying to force those other relationships to go backwards is harder. So it's going to be easier to go this direction, okay? And use your Pythagorean theorem. So if you think x squared plus y squared equals r squared, you can solve for r. Another thing is that it's going to be easier to use tangent in this scenario because tangent is opposite over adjacent, y over x. And so if they give you the x and the y, that just makes that a little bit easier to put them into the same thing. So those are the relationships we're going to use, and we're going to try to convert from rectangular to polar. Now it feels like it takes a few more steps just to get all the math worked out for it, but it's a similar idea. They've given us in this one, they've given us the x and the y this time. And so we're going to use that by plugging that into the x squared plus y squared equals r squared scenario. That's going to be a -2 squared plus 2 squared equals r squared. -2 squared is 4 plus 2 squared is 4 equals r squared. That is 8 equals r squared. And so the square root of 8 is r. Technically, we could have positive or negative, but it's going to be easier on you to use the positive. So we're going to go with the positive. Technically, remember there's infinitely many polar coordinates that we could give and them still be correct. I'm going to go with the ones that are easier to find. So I'm getting the positive one here. And we're going to say, I could simplify that, get 2 root 2 for r. That's what I think is prettier, so I'm going to use that. Okay, so that's r. But to get theta, we're going to have to use tangent, right? So we're going to say tangent of theta equals y over x. And then plug your numbers in, right? Tangent of theta equals 2 over negative 2. So tangent of theta equals negative 1. And so here is where the slight, hiccup is with this type of question. There's technically 2 places on your unit circle where tangent is negative 1. And so we have to figure out which one is the correct one for this problem, okay? So I need you to kind of visualize where we're dealing with here. This is the point, negative 2, positive 2. So on the coordinate system for your x and y's, that's going to exist up in here, right? So I want you to think about what angle measure that would have to be, because technically there's 2 places where tangent is negative 1. It's either at 5 pi over 3. Sorry, not 5 pi over 3. I'm sorry. I was thinking crazy. It's either 3 pi over 4. Excuse me. There's a 3 I'm thinking of. It's either at 3 pi over 4 or it's at 7 pi over 4. It's one of those two. Well, this is 3 pi over 4. So that's the one we want, because that's where that's located, okay? If it had been the other one, we would have used 7 pi over 4 or negative pi over 4. Technically, either one would be fine. All right, so theta is 3 pi over 4. That is a correct answer. And so to give me the full coordinate, I would say 2 square root 2, 3 pi over 4, like that. All right, let's do one more. We're gonna go to C, because I want to talk about a specific thing we're gonna see there on C, okay? Maybe pause the video, try it, come back when you're ready to go over it, or if you get stuck. There's like one particular thing that I feel like we need to discuss on it. So try it, see if you can figure it out, and then start the video back when you're ready to go over it. This is your x and your y. You would plug it into the x squared plus y squared equals r squared. So I'm just going to plug it straight in. 0 squared plus negative 5 squared equals r squared. That's going to be 25 equals r squared. So 5 is r. Okay, so I'm going through that pretty quick. Once you have r, the theta is a little bit trickier to figure out here, and you'll see why. If I look at this, tangent of theta is equal to, remember, y over x. So we're going to say y over x, but we're going to plug those in. So tangent of theta, negative 5 over 0. Anytime you have 0 on the bottom, that means it's undefined. Now, it doesn't mean that you can't solve this one, okay? You totally can. We can figure out what tangent, what angle measure where tangent is undefined is. But so don't give up and say that you can't do it, because you can. It's not like there's a no solution. We need to figure out where is tangent undefined. So you think about tangent. Tangent is sine over cosine, or y over x, right? If tangent is y over x, I need to know where is x, 0 on your unit circle. And there are 2 places. So here's another way to help you figure it out. Look at this coordinate, 0, negative 5. On your xy system, 0, negative 5 is going to be down here somewhere. Okay, that angle measure is 3 pi over 2. Okay, so, and also coincidentally there, tangent would be undefined because x is 0. So theta is going to be 3 pi over 2 here. It's not like theta is undefined, right? Theta actually is. So my point would be 5 and then 3 pi over 2. Yeah. All right, guys. So there is a tiny bit more to this that we need to talk about. I do not have time to put that in this video because my lunch is over in 5 minutes. So I will make a part C, it should be fairly short, of me going over the last little bit of this section. So definitely look out for that. That's the one where we're going to bring the complex plane back into it, get imaginary numbers. So if that is what you're looking for, then please make sure that you go and check that video out. And I will see you in the next one. Bye.